Good day, everyone. Welcome to today's science class. My name still remains Miss Ifeanyi Joseph, and in today's science class, we're going to be looking at electric circuits. So stay tuned. It promises to be a fun and interesting class. So our objectives for today's class is very simple. We're going to be exploring the concept of series and parallel circuits and how they are used in the real world. So in today's class, I just need you to learn the following electric circuits, closed and open circuits, series circuit, parallel circuits, and learn what the circuit diagram is. So basically in today's class, we're going to be learning everything there is to know about electric circuits and its application in our everyday lives. So it's going to be a fun and interesting class. So please stay tuned and learn something new today. So first of all, we're going to be starting with a simple definition. What is an electric circuit? Now, an electric circuit is a closed loop that allows electricity to flow. When we talk about circuit, we're just talking about a pathway through which electricity flows. This electric is just simply a pathway that allows electricity to flow. Now, to make your simple circuit, you need some basic components like your power source, which can be your battery, your conductors, which are your wires, and a load such as bulbs and the rest, as you can see in that diagram. Then you have like a switch that can be open or closed to control the flow of electricity. Now we have two types of circuits. We have the opened and we have the closed circuit, which you can see on your screen there. Now, if the circuit switch is closed, electricity flows through all components. Now, in order for electricity to flow properly, the circuit has to be what? Closed. In order for electricity to flow properly, the circuit has to be what? Closed. That is, there is no break in the components. Everything is what? Closed. As you can see there, starting from the battery, through the wires, down to the bulb. There is no open part anywhere. It has to be closed. That is the only way electricity can flow through all the components. And that is a typical example of a closed circuit. While for your open circuit, is if the current circuit switch is open, electricity cannot flow through all components. Now, when there's a part that is open, electricity cannot flow. Like if you look at the diagram there, you can see that the switch there is open, so electricity cannot flow through it. So in this case, the light bulb will not on because there is no proper flow of what? Electricity. So in order for electricity to flow properly, and then there should be light just like the way the light bulb is on here in the closed circuit diagram. The circuit has to be well closed. That is, there is no open component anywhere for electricity to flow properly. Now, that brings us to series circuits. So now, what is a series circuit? In a series circuit, all components are connected end to end in a single path. Now, when we talk about series circuits, all the components are connected end to end. That is, they are on a single path, and all of them are connected from one end to the other, just as you can see in that diagram. And there's various characteristics of the series circuit which you can see on the screen. The same current flows through all the components. Now, when they are on a single path like that, it's the same amount of current that flows through all the components. And if one component fails, the entire circuit stops working. That's one characteristic of series circuit, that once one component stops working, everything else stops because they are all working on a straight path from one end to the other end. So if along that path anything stops there, electricity stops flowing immediately. A circuit switch which control all the flow of electricity through all the components. So these are the various characteristics of a series circuit. Now, a real-world example of a series circuit is our typical coffee maker. A coffee maker operates using series circuit, linking the power switch, heating element, and indicator light in a single path. So your coffee maker is a typical example of what a series circuit, where everything flows in a direct path from the light switch to the heating element to the indicator light. Everything flows in well. If there is a break, maybe through the switch or through the heating element, that machine is not going to work because there has been a break in the flow of electricity. So that's what a series circuit is all about. Now that we know what a series circuit is, what is a parallel circuit? Now, a parallel circuit, components are connected across common points, creating multiple paths for electricity to flow. Now, in your parallel circuit, unlike your series circuit, everything are on a single path. But in this case, everything are not on a single path, they are on multiple paths, but they are all connected across a common point. They are on multiple paths, but they are all connected across a common point. This allows electricity to flow, but not on a single path like the series, but on multiple paths, as you can see in this diagram. Electricity is flowing through various pathways, but the circuit is closed, so electricity can what flow. Now, some of the characteristics of these parallel circuits are: each branch receives the same voltage. If one component fails, the other branches continue to function. Unlike a series circuit, when one component fails, electricity stops flowing. In this case, it's not like that. When one component fails, the other branches are allowed to carry on. A circuit switch will control the flow of electricity through all the components. A real world example of this is your car headlights. In most cars, the headlights are wired in parallel. This ensures that if one headlight burns out, the other will continue to function. That's why most times, if you see some cars, one headlight is working, the other headlight is not working. That's because the wires for these headlights are connected in parallel. So if peradventure one component stops working, the other components are still functioning to make sure electricity is flowing and light is giving off at the end of it. So here is a diagram of your series and your parallel circuit so you can have a better view of what we are trying to say. As you can see in your series circuit, just one part where all components are following a single pathway, and in your parallel circuit you can see there are multiple paths with branches that can work independently if the peradventure one fails. So you can see that on your screen, it's how they are. So we have on the screen a circuit diagram. Now, circuit diagrams are used as representations of actual electric circuits. So it's not every time you might have actual electric circuits, batteries, bulbs, and stuff. Most times we use these diagrams to show how electric current flows. So this is it. So some of the characteristics of a circuit diagram is that symbols are used to represent actual electrical components. Lines are used to represent wires that connect all components, and circuits are shown as a closed loop. If you can see the loops on your screen. You can see that they are closed to tell you that this circuit is closed and electricity can flow properly through. So we have how to read the circuit diagram. Now you can see the actual circuit there, and then you can see the circuit diagram. Now you can see the difference and how you can be able to identify each of them. Here the load is the light bulb. In the other side you can see the load. You can see the switch, which is the loops that was closed in the previous slide that we just saw. You can see that here it's kind of open. You can see the power source and you can see the wire. So this slide here just shows you how those circuits are represented on the circuit diagram. So when you see something like this, you can be able to interpret it clearly what each of them mean. So in summary, series circuits provide one path for current, while parallel circuits provide multiple paths. So in conclusion of all we've learned today, we've learned that series circuits provide one path for current, while parallel paths provide multiple paths. It's such a case that even when one path fails, current can still flow through the other remaining paths. We also learned that closed circuit allows for electricity to flow. So in order for electricity to flow, our circuit has to be what? Closed. An open circuit do not allow for electricity to flow. So once your circuit is open, electricity cannot flow. If there is a break in the pathway of electricity, electricity will not flow. That means that circuit is open and it will not work. And also we learned about the circuit diagram, which helps us to visualize the stuffs of electric circuits even without the actual components being present. So I hope you've enjoyed today's class as much as I've enjoyed it, and I hope you learned something new. So when next you're turning on that light switch in your house, you should be able to have or visualize how the electricity is flowing from that light switch to your light bulb. So I'll see you in the next class. Do enjoy your day. And if you have any question, please do not hesitate to leave them in the comment section. Thank you. Bye.